back side of the view, graphing. Sorry I cut out on that. When you graph and need to answer all these questions, first thing you need to do is factor and see if anything cancels. Something will cancel. So this is f of x equals x plus 1, and this factors to x plus 1, x minus 1. The x plus 1's cancel, and I'm going to be looking at 1 over x minus 1. Remembering that there is a hole at x equals negative 1. X-intercept, that's where when the numerator equals 0, will the numerator ever equal 0? No, so you would write none. Don't leave it blank. Write none. Y-intercept, you plug in 0 for x, so that's 1 over 0 minus 1, or 1 over negative 1. So it is negative 1. Vertical asymptote is when the denominator equals 0. So that's x minus 1 equals 0, or x equals 1. Horizontal asymptote, where's the biggest exponent? The biggest exponent is in the bottom. So it is bottom heavy. You don't have to write this. This is just the terminology I use. Bottom heavy, that means there's a horizontal asymptote at y equals 0. And I believe the next and last question on there is, where's there a hole? There's a hole at the parenthesis you canceled. There's a hole at x equals negative 1. So you don't actually have to graph on this one, you just need to answer my questions. So do not freak out. The next one you'll have to graph, and I don't think it's awful. I'm sure to you it's terrible. But I think you'll be all right. Show all the steps. First thing you need to do is check to see if I can factor and cancel. Nope, I'm not going to be able to factor and cancel. There is no hole. So, x-intercept. When will the numerator equal 0? At 0, when x is 0. Y-intercept. I plug in 0 for x. 0 over 0 minus 4. That's going to end up being 0. Vertical asymptote, when does the denominator equal 0? That's at x equals 4. Horizontal asymptote, they have the same degree. So I divide the numbers out in front. 1 over 1 equals 1. So at y equals 1. And there is not a hole. So hole, there is none. Okay, so hole, don't leave blank, put none. All right, so we need to graph this. Vertical asymptote at x equals 4. 1, 2, 3, 4. I need to move this up a little. Sorry about that. There we go. Horizontal asymptote at y equals 1. I have a x-intercept and y-intercept at 0, 0. So the graph is going to be, part of the graph is going to be over here. So it's going to curve closer and closer to the asymptote, closer and closer to the asymptote. Now where is the other part of the curve? Is it up here, down here, up here? Well, you need to plug in a point. I'm going to plug in a point over on this side. Is it on the top or the bottom? I'm going to plug in x equals 5. So if I plug in 5, I'm going to get 5 over 5 minus 4, which is equal to, I believe, 5. So if I plug in 5, 1, 2, 3, 4, 5, I get 5. 1, 2, 3, 4, 5. So it is up here. And it's going to get closer and closer to the asymptote, closer and closer to the asymptote. And that is my graph. The last one is not supposed to be hard, but you're going to get a point taken off if you don't listen and follow directions. It says to make a list. Now it says to use P over Q, but it does not simply say to write P over Q. It needs a list. What are the possible zeros? Well, most people would remember P over Q and say, hey, what multiplies to give me 9? Plus or minus 1, plus or minus 3, plus or minus 9. And then what multiplies to give me 3? Plus or minus 1, plus or minus 3. You do this and I'll take a point off. That is not a list. You need to take all these numbers on top and divide by 1. Super easy. plus or minus 1, plus or minus 3, plus or minus 9. And you have to divide all of these by 3. 1 divided by 3 is a third, plus or minus 1/3. 3 divided by 3 is 1. We already have 1, but if you would like to repeat it, I'm not going to take it off. 9 divided by 3 is 3. And I'm not going to take it off if you repeat it again, but this is what I'm looking for. I am not looking for simply P over Q. I want you to know that 1/3 is also a possible 0. So that is the last problems I'm going to be doing for chapter number 2. You can look at my other videos, ask me questions. Test on Monday.